For our FRQ problem, we got question 6 from the 2013 AP Calculus test. It asks us to consider the differential equation dy over dx equals e to the y times 3x squared minus 6x. Let y equals f of x be the particular solution to the differential equation that passes through 1, 0. For part A, it asks us to write an equation for the line tangent to the graph of f at the point 1, 0. Use the tangent line to approximate the value of f of 1.2. Part A, the first thing we must do is find dy over dx. This is the slope of the tangent line. To do this, we plug in the point 1, 0 in the equation. By evaluating this equation, we should get that dy over dx is negative 3. This is the slope of the tangent line. After finding the slope, we must plug this in to the equation y minus y1 equals m times x minus x1. We should then get y minus 0 equals the slope, which is negative 3 times x minus 1. This should simplify to y equals negative 3 times x minus 1. The problem then asks us to approximate the value at f of 1.2. To do this, we simply just plug in the point 1.2 as the x value and solve. We should then get negative 0.6.
A total of 3 points can be awarded for part A. The first point is awarded for the correct slope at the point 1, 0. The second point is awarded for the correct equation of the tangent line, and the third point is awarded for the correct approximation of f of 1.2. First, Mr. Calculus plugs in the coordinate pair 1, 0 into the equation dy dx equals e to the y times 3x squared minus 6x to find the slope of the tangent line. Then he plugs both the slope and the coordinate pair into the tangent line equation y minus y1 equals m times x minus x1. With that equation, he can plug in 1.2 for x to find the correct approximation of f of 1.2. The first student received full credit because they had the correct slope at the point 1, 0, and then they used that to find the correct tangent line equation. And then they correctly plugged in 1.2 for x to solve for f of 1.2. The second student was awarded the first point for calculating the correct slope at the point 1, 0, but they plugged in incorrectly into the tangent line equation, giving them the wrong equation for the tangent line. And no points were awarded for the correct approximation of f of 1.2. The third student was awarded the first 2 points for finding the correct slope at the point 1, 0 and finding the correct tangent line equation, but they weren't awarded the third point because they didn't plug in to find f of 1.2.
Part B of the problem asks us to find y equals f of x, the particular solution to the differential equation that passes through the point 1, 0. So we start by writing down the original equation, dy over dx is equal to e to the y times 3x squared minus 6x. And then we separate the variables so that all the y's are on one side and all the x's are on the other side. So it'd be 1 over e to the y dy equal to 3x squared minus 6x dx. Then we find the integral or the antiderivative of both sides. So we'd get the integral of 1 over e to the y dy is equal to the integral of 3x squared minus 6x dx. That is, you could simplify that to be equal to e to the negative y dy equal to the integral of 3x squared minus 6x dx. When we solve for that, we get negative e to the negative y is equal to x cubed minus 3x squared plus c, which is the constant of integration. We can solve for c. Solve for c by plugging in the 0.10. So we get negative e to the negative 0 equals 1 cubed minus 3 times 1 squared plus c. When we solve for c, we get c equals 1. So what we do now is plug in c into the original equation, which would be, so we take the equation and plug in c, so we get negative e to the negative y equals x cubed minus 3x squared plus 1. We simplify for y, starting with distributing the negative, so it's e to the negative y equals negative x cubed plus 3x squared minus 1. Then we find the natural log of both sides, and you get negative y equals the natural log of negative x cubed plus 3x squared minus 1. And we distribute the negative again to get the final answer of y equals negative natural log times negative x cubed plus 3x squared minus 1.
So for part B of the problem, there are 6 possible points that you can earn. The first point is for separation of variables, which is separating it so the y's are on one side and the x's are on the other side. The next 2 points you can earn are for taking the antiderivative of each side of the equation. And the fourth point is for adding the constant of integration, which is the plus c, after you integrate each side. The fifth point is for using the initial condition, which is the 0.10, in finding what c equals. And the last point is solving for y to finish the problem. So for part B, Mr. Calculus from Ask Mr. Calculus basically starts off solving the problem in the same way that was shown earlier, except at the end he gets 2 different answers. The first answer is y equals negative ln of negative x cubed plus 3x squared minus 1, which is the same answer that we got earlier. But he also gets an equivalent solution of y equals ln of 1 over negative x cubed plus 3x squared minus 1. So for the first student solution for part B of the problem, the student earned 6 out of the possible 6 points. They got the first point for separation of variables at the beginning, so getting all the y's on one side and the x's on the other. Then they got the next 2 points for taking the antiderivative of each side, and the 1/4 point for the constant of integration. They then plugged in the initial condition of the 0.10 and got the 5th point. And then at the very end, they solved for y, giving them the 6th out of 6 points for the problem. And for the third student solution for part B, the student earned 1 out of the possible 6 points for the problem. They earned the 1 point for doing the separation of variables into x's on one side and y's on the other. However, they incorrectly took the integral of each side, resulting in them not receiving any of the 5 remaining points of the problem. So for the second student solution for part B, the student earned 5 out of the possible 6 points. The student earned the first point for the separation of variables into the y on one side and the x on the other. They got the next 2 for taking the integral both sides. They got the fourth for the constant of integration, and the fifth for plugging in the point 1, 0 into the equation. However, the student did not get the final sixth point because their final answer contained a +3, or it contained a -3 instead of a -1 because they incorrectly solved for C, getting that C equals 3.
Common mistakes on part A include not knowing that dy over dx is the slope of the tangent line and incorrectly plugging in the point. Common mistakes for part B include not separating the variables by having dy on one side and dx on the other side, not finding the antiderivative correctly, and not finding the natural log of both sides in order to solve for y.